Good afternoon, everybody, and a very, very warm welcome to you all. It's fantastic to see this packed room here. I'm Mark Anderson from the Net Zero Technology Centre, and I can't wait to see what we've got in store for you this afternoon. So, a very warm welcome to the Decarbonisation Technology Challenge Final. This is the day we've all been looking forward to for some time. In fact, from back in May, when ADNOC announced this challenge at UAE Climate Tech in Abu Dhabi. And this is the day when we'll find out who has won a staggering $1 million piloting opportunity with ADNOC. And what a fantastic prize that is, and what an amazing opportunity. So climate tech startups need to be able to trial their technology in order to scale up and commercialize it. These trials highlight what works well, what perhaps needs changing, and crucially, the greenhouse gas reduction impact that the technology could provide. With digital technologies, a trial can be relatively simple and low cost, but with hard tech, it is more difficult. It needs goodwill and resources from a willing customer. And in launching this amazing $1 million competition, ADNOC has shown its strong and continued desire to work with climate tech startups to trial their technologies and help them in their commercialization journey. They are the willing customer. It's great to be at COP28 in this inspiring green zone, in this fantastic pavilion. And we know from discussions taking place around this expo centre that we have a massive challenge on our hands to achieve net zero. And I'm going to quote the IEA. Net zero by 2050 will require huge leaps in clean energy innovation. 35% of the projected abatement in CO2 emissions required to reach net zero by 2050 will need to come from technologies that are currently not commercially viable. And much of that 35% will need to come from startups like the 10 we will meet this afternoon. And I'm now going to pass you over to my colleague, Edward, who's going to tell you more about what's in store for you today. Edward.
Thank you very much. So Mark and I from the Net Zero Technology Centre are delighted to be taking you through our event this afternoon, where we're going to have a packed schedule of 10 startup pitches. Each startup has to challenge themselves to deliver a 5-minute pitch. We know how the clocks work. Make sure, 5-minute pitch. And then they're going to be put on the spot with questions from our panel of judges. And they have been tasked with showcasing their game-changing decarbonisation technologies here for you today and convincing the judges why they are worthy of that amazing award. Now, their pitches have a lot to cover. The judges are going to be looking for some key things, so maybe you could join along with them and see if you could spot them. So one of the things they have to demonstrate in these pitches is technology innovation. Why is this technology a game changer? Why is this something that the world hasn't seen before? And why are these startups deserving of that prize? The next one, we're at COP28. It's all about decarbonisation. This is about decarbonisation impact. How will this technology shift the dial in terms of our global emissions and also in particular here in the UAE as well? It's also about the technology development. If you're going to be getting a great piloting opportunity, you need to be able to deliver it. So can the startups demonstrate that they are ready for that? They've developed the technology, it's in a good position, and they are capable of delivering it. And then the final thing, of the fourth thing the judges are looking for, is pilot potential. Could this technology work here? Could you start scaling up and delivering that technology so that post-COP28, the winner from this competition actually goes out there and starts saving carbon from today? Fingers crossed, once they start building that technology, it is all possible here on this stage today. So there's lots to look out for, and lots of amazing audience coming and going over the next couple of hours. And we're also not just live here in a packed out green zone, but also to those who are watching on our live stream or who are watching this back later on, a massive welcome. Thank you for tuning in to our broadcast today. Well, I think it's time to get this show on the road. So I think, Mark, over to you to introduce our keynote speaker.
Thank you, Edward. And we're very honoured to have Masabe Kabi, Executive Director, Low Carbon Solutions and International Growth at ADNOC, here for our keynote speech. Masaba, you're very welcome.
Thank you. Thank you. Truly pleasure to be here today. I would like to welcome all of you. This is a very important event for an energy company like ADNOC. And I'm not exaggerating. I think technology is going to be at the heart of all the, energy transition going forward. So let me start by thanking our partners. So I'd like to have special thanks for PP, AWS, Hub 71, Echo from the past. Huh? We work together. And the Center of Decarbonization Accelerating Center. So when we look at the energy transition as an energy company, there are two key enablers. One of them is policies. And many of you will share my views about policies, and we don't have sometimes a high level of confidence that the right policies will be introduced at the right time. But the other enabler is technology. And if there is something that I have full confidence in, it is technology. I joined the industry in the late 90s. And since then, I have seen technology disrupting our life right and center. It's no secret that 2007 was potentially reshaped our daily life today. I don't know if you remember what happened in 2007. Anyone can guess? Come on, this is technology event. Steve Jobs, the introduction of iPhone. And one time I was asked, what is an iPhone? What is the I stands for? It's an interactive phone. So, and by the way, at that time, Apple, they were asked, what is your strategy? And their strategy was very, very simple. Turning the ordinary into non-ordinary. And Steve Jobs also was asked one time, what is your ultimate goal in life? And his answer was very simple, to leave a dent in human history. So if there is one request from me today to all of you and to the technology ecosystem, I would like you to leave a dent in the human history. So please don't underestimate the role that you're going to play. I am personally very, very committed, and I was extremely happy to see 650 startup companies applying to this decarbonization challenge from almost 40 countries. And to my positive surprise, there were also some local companies applying to this challenge. And you will hear from some of them today. So looking forward for us engaging with you, accelerating our plans, solving the energy transition, and achieve the right outcome for humanity. We as ADNOC very committed, and hopefully will pick the right technologies and support the right technologies that will achieve the ultimate goal for a big event like this. So thank you again. Very exciting event, and I'm not exaggerating. Maybe this is a very important excitement for ADNOC. We've been around and meeting a lot of people, but this one in particular is very critical to us. So thanks again, looking forward, and please let's stay optimistic about the climate agenda. When I see faces, technology, I remain very optimistic. Thank you.
How can we accelerate the pace of decarbonization? We look to the innovators, pioneers with new ideas, who can help reshape the global energy landscape. The ADNOC Decarbonization Technology Challenge drew 650 global applicants. Among those, 10 game-changing companies with next-generation technologies, ready to pitch for $1 million in piloting opportunities and access to state-of-the-art research and innovation facilities to take their technology to the next level. The cutting-edge technologies include
innovations in carbon capture and utilization, cognitive AI to reduce operational emissions, kinetic batteries to decarbonize remote operations, direct CO2 air capture techniques combined with desalination plants, composite pipe technology to help transport hydrogen, genetically modified bamboo plantations that maximize CO2 removal from the atmosphere, advanced valves to eliminate emissions, ultra-lightweight flexible solar films for the built environment, innovative wind-powered CO2 capture, a circular solar thermal water desalination system. These 10 companies from around the world have the potential to accelerate the energy transition and help to make net zero a reality. Let the pitching begin.
Wow, can you believe it? 650 applications down to just 10 here today. And in a few hours' time, one lucky startup will be awarded that amazing pilot opportunity. So before we get started, let's run through a few details just to be aware. So for those of you who are in the room, you may have noticed we have cameras, we are live streaming, we're taking videos and pictures. So just keep that in mind, your image may be captured, so just for your awareness. Now, the event is open access, so you're very welcome to come and go as you please. The bathrooms are in the visitor center across, so not in this pavilion. So if you do need to leave, then please make your way to there if you have to. And also, the Grand Challenge winner will not be announced until the very end. So we encourage you to stick around for as long as you can to get to that big announcement at the end of the event. And with our schedule, just to keep you in mind, we're going to do 5 pitches and questions. So it will take roughly an hour, and then we're going to have a break. So you will get a breather. It will get hot in here. So you will get a breather, and there'll be some food and drink available for you in that break. And then we're going to come back in, and we're going to hear 5 more pitches as well with some Q&A. And then around 4 o'clock, our judges have the difficult task of having to pick a winner. So again, there'll be some more food and drink, and please stick around. And as soon as the judges have a decision, we will be back in here. We'll be back online, and you will find out who our winner is going to be, probably ending by roughly after 4:30 p.m. today. Okay? And if you want to follow along on social media, if you're watching online or you're in the room and you're supporting a startup and you want to see them win, feel free to use #DecarbChallenge. And you can use that on whatever we call our social media these days. They keep changing names, but whichever one suits your fancy, feel free to go for it. All right. I think it's time to get going, but we're missing a few people on the stage, Mark, so I'm hoping you have an answer to what to do with that.
Thank you, Edward. I do. And I'm very, very pleased to announce our 5 judges drawn from our partners. So without further ado, please welcome Ali Al-Ruhahi, Senior VP Technology and Innovation, ADNOC, onto the stage. And next, I'd like to welcome Shaima Sharif, Global Innovation Programs Lead, AWS, onto the stage. And next, I'd like to welcome Myrtle Dawes, Chief Executive Officer of the Net Zero Technology Center, onto the stage. And I'd next like to welcome Mohammed Al-Naki, Hydrogen Business Development Manager, BP, onto the stage. And lastly, I'd like to welcome Ahmad Ali Alwan, Deputy CEO, Hub 71, onto the stage. So, over to you, Edward, to kick things off.
Here we go. It's time to get our pitches started. Are we comfortable, judges? Are we feeling ready? Fingers crossed. Okay, well, our first startup today is all about acceleration, and that is something familiar to the founding team of our first startup today, because our first startup has a CEO whose previous appearance on the TV show Top Gear went viral, and a head of R&D whose grandfather actually co-invented the mini car. So hopefully they've taken all of that talent and skill to accelerating something different in the energy transition space. Please welcome to the stage our first pitch of the day, Beena Sharma from CCU International.
Thank you. Thank you. Right, well, According to the UN, it is unlikely that we can limit the devastating impacts of climate change without some form of carbon capture. Carbon capture is a key technology in the UAE in achieving net zero by 2050 and beyond. Whilst ADNOC have advanced their target to 2045 and have identified technology as a key enabler in reaching that target. Without carbon capture, industries face rising emissions, carbon tax, reputational damage, loss of customers and partners as the demand for sustainable products and businesses reach its peak. My name is Beena Sharma, and I'm the CEO and co-founder of CCU International. I'm here today to introduce to you our next generational patented carbon capture and refinement technology. And I'm here also to introduce our technology for the purpose of the pilot with ADNOC. Fossil fuel combustion and industrial processes in the UAE generated 218.8 million metric tons of CO2 emissions in the UAE alone in 2022. Our technology prevents these emissions from entering the atmosphere in the first place by capturing the CO2 emissions directly from any industry chimney, flue, or exhaust stack. We can also take that captured CO2 and create marketable products such as synthetic aviation fuel and sustainable building materials. Unlike traditional carbon capture methods, our technology has a small footprint, is modular, scalable, cost-effective, and does not use any hazardous substances. No amines. Our energy consumption is low, and we're able to run on renewable energy, making our carbon efficiencies amongst the best in the world. We use a pressure swing adsorption system. Our IP sits in the pressure profiling, which enables us to purify the CO2 to any grade, future-proofing it for utilization and storage. Our sorbent material is a dry substance, it's non-hazardous, and we do not envisage any supply chain issues or permitting issues. The sorbent is our know-how. So how does our tech work? Flue gas, a mixture of CO2 and other gases, is fed into the capture system where it is pressurized. Once the column fills, the CO2 sticks to the sorbent material whilst the other gases do not. After an amount of time, the column is depressurized, venting the other gases, such as nitrogen. This vent can be used to generate power via a turbine or even help run the pressurization process in the carbon capture rig. Further energy recovery can be obtained from the heat generated during pressurization. The column is vented for a second time, and this moderately enhanced gas can be fed back into the system to be enriched further. The column is then depressurized again, and the remaining high CO2 enriched gas comes away from the sorbent material where it is collected for storage or utilization. Our technology has undergone intense R&D at the University of Sheffield for over 10 years. And we have gone from technology ready level 2 to 7 in less than 18 months. With the deployment of our capture system for Unilever this month, we will move swiftly into TRL 8, and we're hoping to move into TRL 9 sometime in 2024. The proposed pilot with ADNOC would look to capture 10 tons of CO2 a day from an emitting plant with CO2 concentrations of 10 to 12% minimum. This would ideally be from an oil-burning source like a power plant or a refinery. The pilot would look to capture emissions from the stack over 3 to 6 months, following several months of planning, design, and engineering. But this data would provide us with enough sufficient analysis to provide a timeline which would include a bespoke system for the plant. What does this actually mean for ADNOC, though? So in theory, the technology should not experience conventional challenges when scaling up. Scaling up for us involves adding more columns or vessels, and we call this scaling out rather than scaling up, therefore significantly reducing the technology risk. If we were to build 5 capture systems of 10 tons a day, or we were to build one 50-ton-a-day capture system, over the lifetime of the project, which is 15 years, we would be looking at emissions capture, which is equivalent to, for example, planting 9 million mangrove trees. ADNOC have a target of 10 million by 2030. This is just with one capture system. If we captured 1,000 tonnes a day with one capture system over 15 years, this would be equivalent to planting 185 million mangrove trees. Our team have combined experience of over 50 years in both carbon capture and environmental technologies. We've worked on multiple carbon capture projects, including the first ever carbon capture project in the UK. So we are well placed to lead on a pilot with ADNOC. Our technology is half the size, half the energy consumption, and half the cost of conventional methods. We can get you to net zero faster, cost effectively, and more efficiently. Our technology is compact, affordable, and efficient. Thank you.
Thank you, Bina. So we now have 5 minutes of questions from our judges. So who would like to go first? A question for Bina. Myrtle. It's always on, so just start talking.
Thank you. Thanks. So great technology. And my question's about the purity of the CO2 coming out. So ideally, circularity is what we're looking for, so we're looking to use it rather than it be a waste stream. What's the purity and what's the use cases for your CO2?
Yeah, that's a really good question, actually. We get asked this question quite a lot. So one of the key things about the technology is that we are able to process the CO2 and provide any purity of CO2. So, for example, we can use it in the carbonation process, in the mineralization process for construction material. 50% purity is all that's required. The industry at the moment are being forced to purchase food-grade CO2, which is quite expensive, but we can also purify to food-grade, and interestingly, we can also use the captured CO2 for the food and drinks industry because we don't use any hazardous substances. So it can go back into drinks companies, beer companies, etc. And then also, because we have the ability to purify even further, we can take that to medical grade as well, although there's not much of a market for it, but we can do that. And often with the liquefaction process, that will take the purity further up. So there are multiple, the reason why this technology was developed was so that we were able to future-proof and utilize the captured CO2 for whatever the application looked like, so it could be sustainable fuels. So at the moment, we're working with Unilever, and we're taking captured CO2 from the steel and paper mills, and we're looking to create surfactants, which 3 products are fairy washing up liquid, Dettol, and finished dishwasher tablets, which CO2 goes into.
Okay, who else has a question? Ahmed.
Thank you.
Just talk, yeah.
Thank you for the great question, Bina. So you mentioned Unilever, so I wanted to just build on that. What has been your traction been so far? Who are you working with? Have you received investment so far? I want to understand maybe a bit more on the use cases, perhaps a bit more granular than what you just mentioned, maybe with one of your clients.
Thank you, yeah. So we do have a demonstration capture system, which is actually currently working with live flue gases at a steel plant, Liberty Steel in the UK. The Unilever project itself involves 15 blue chip companies, so Unilever, Procter & Gamble, BASF, Tata Steel, and it's backed by UK government as well. And the idea behind that was to create the circularity of CO2, so create a full circular economy where not only do we capture the CO2, but we also utilize the CO2 back into industry to avoid what Unilever call, rather than decarbonization, they call it defossilization, to remove reliance off of virgin fossil fuel. So that was the idea behind that. Currently, we are working with a number of downstream technologies to provide things like sustainable aviation fuels. But there are 2 things we're doing with Unilever. One is the surfactants, and interestingly, it comes very close to DME, which is diesel. So very, very close to that. So we're not far off from that either. Thank you.
Okay, Shaima.
Could you tell me more about your technology differentiation? Who are your competitors in the market? Thanks.
Yeah, sure. There are lots of different technologies that are coming up. You know, the biggest issue that we've got at the moment is existing technologies actually haven't changed very much. I think the first patent for carbon capture technology was put in the 1930s. If you look at the technology that's being used now, it actually hasn't changed very much, apart from some of the chemical substances that we're using. So our process is not a chemical process whatsoever, so we don't have any environmental concerns. What happens is it's a physical reaction. So the big differentiation is because we're not using any hazardous substances which require post-processing or heating or cooling, our capture system works at ambient temperatures. So we're not requiring heavy amounts of energy, and we don't have to clean the CO2 afterwards of its hazardous substances. So the biggest differentiation is the cost, not just the cost, but the cost of the OPEX, the CAPEX, as well as the size of the capture system. And the fact that we don't use hazardous substances means that it can be utilised back into those industries where there's high demand for CO2, which is the food and drinks industry.
Okay, I'm afraid we're now out of time, so thank you very much, Bina.
Thank you. Thank you.
Okay, now our next pitch is also hailing from the UK, this time from Oxford. And our finalists, if they are ready to wrestle climate change, I guess they've also got experience, because our next finalist boasts 2 judo instructors in their team, and their marketing manager won a gold in a recent European Masters Athletic Championship. So fingers crossed they might win gold today. Please welcome our second pitch of the day, Chris from Oxford Flow.
Hello everyone, I'm Dr. Chris Kennell with Oxford Flow. Today I'm going to be talking to you about our innovative valve technology that we're using to reduce and, eliminate fugitive emissions. To kind of set the scene a bit, to start, industrial fugitive emissions, 60% come from valves. This is a huge contributor overall. If you think about a single valve, not much, but there are valves everywhere in industrial facilities, so it all really does add up. So this is a massive problem to address. When you actually look at a valve, interestingly, on the traditional valves, all of the emissions come from a single point, the stem and the stem packing arrangement. This is the dynamic assembly here that's moving in the center of the valve. As this moves, you need dynamic seals. Over time, they wear out. You get emissions from the valve. So for us, when we were approaching this, looking at, okay, how can we remove these emissions? For us, the solution was obvious. Design a valve without that interface, just completely remove it. So that's what we've done. Our ES series products has no stem or no stem packing, so really solves the problem at the root cause. If you take a look at the technology, how we've done this is actually integrate that actuation inside the valve. So now, instead of a mechanical system needing to go through the valve body, this is driven by a direct hydraulic drive. So as I said, fundamentally removing that problem at the source. So by filling and draining internal hydraulic cavities within the valve, we can shuttle the plug between open and closed. And as I said, all of that actuation package is inside, so you don't need to have all of those top works anymore. And it's eliminated those emissions right at the source. That was the most important key difference for us. The competitors, they're just trying to bring out better stem packing, better sealing arrangements. That's just remedying the problem. We're trying to solve it. In terms of technology readiness level, we've been working on this for a couple of years. We're on TRL 8 right now. So we have done some temporary deployments of the technology to test basic functionality. These were on real sites and on a variety of different applications as well. And now we're really ready to move on to the next step. So in terms of the pilot, the nice thing about valves is you've got quite a wide range of sites to select from. You find valves everywhere in industrial facilities. They're standard dimensions. According to ASME API, you can fit them in a standard gap. No major infrastructure requirements beyond what you normally need. And there's a wide range of compatible applications, whether that be retrofit or emerging markets such as hydrogen. And it's already certified to all of the expected industry standards, so completely safe to use. and you can measure the success, quantify the emissions reduction. You can look at that compared to something you saw previously on the traditional technology, and quantify the application performance as well, whether that be control accuracy, shut-off class. So what difference would all of this make in terms of decarbonisation? So if you look at a single valve, you're looking at around 7 kilograms per year of CO2 equivalent reduction. Not much, but if you look at that on a facility level, say one of the facilities I'm currently working with, it's got 125,000 valves on a single location. So scaling that up, that's over 1,000 tons of CO2 per year that you're eliminating there. That's equivalent to just over 1,000 flights between the UK and the UAE. And obviously this can be replicated across many different sites across the globe. So for us, how do we reduce emissions? It's obvious. We eliminate them. Thank you for your time, and I'm happy to take your questions.
Thank you very much, Chris. So, yes, Mohammed.
Thank you for the presentation. So just two questions. In terms of piloting or uses for the valve, are you looking at like utilities or hydrocarbons? And two, in terms of use them for hydrocarbons, can we use them for normal use during the processing plant and safety valves, or do you differentiate between the different models that you have?
So really, this can be applied across quite a wide range of applications. Obviously, within the facilities, we can look at the distribution. Hydrocarbons, obviously, that's one of the main areas we're trying to reduce the emissions, and there's a lot of retrofit opportunities there, especially if you've got typically call them bad actors within the facility in terms of emissions. Those are the key hotspots we'd like to target first in terms of utilising this technology to have the biggest impact. But as I also said, this is ideal for kind of emerging sort of new facilities as well, such as hydrogen, because when you're switching to hydrogen, a much smaller molecule, it's going to start leaking out of places. Conventional valves won't be up to the job. So this technology is also ideal for that. Thank you.
Who would like to ask a question next? Ali.
Thank you very much. Very promising technology. We are facing, it's not really in particular, UAE in particular, but it's all over the world about the methane abatement in particular. We've done a lot of monitoring, but not really abatements. So what's your plan here, for example, in UAE or in ADNOC in particular? So how you are going to deploy this technology?
Great question. So in terms of the UAE, as I said, our initial plan would, if successfully working with ADNOC, start to look for those retrofit opportunities initially, look at the facilities, potentially collaborating with one of the other excellent technologies here, identifying where those emissions hotspots are and where would be the ideal sites to start trying this technology out. Obviously, getting ADNOC's input and really scaling this technology up. As I said, there's hundreds of thousands of valves out there, so it's just about getting going and having the best impact on those few key pilot sites.
Thank you.
Thank you.
Yeah, Ahmad.
Thank you, Dr. Chris. And this is for me to make sure I have as informed of a judgment on your technology. And for a person who is not very close to the how factories operate and fab, I understand there's a huge potential on emissions. But could you, in layman's terms, explain to me how does the valve reduce? What's the technology that exists today in these factories? How does your solution differ significantly in terms of the isolation and the emission reduction? And what are the applications when it comes to hydrogen? Because that's very appealing for different industries.
Sure. So in terms of how it's different, so valves fundamentally haven't changed for like 100 years. The designs have remained pretty static. Existing manufacturers have just been kind of iterating on those designs. So as I kind of showed in the presentation, typically you have a valve actuator that sits on top of the valve. This drives a mechanical system into the valve that turns the ball, slides the plug, depends on what sort of valve. They all work in the same way. That sliding part needs seals around it. Over time, these seals, they wear out, they fail, they cause emissions. Everyone else's solution at the minute, put better seals in there. over time they'll still wear out and fail. It will just get you more cycles. So for us, we really needed to kind of think differently and take this kind of blank piece of paper thinking. And that's how we decided to fundamentally change the technology to solve the problem at the root cause. In terms of hydrogen, as I briefly mentioned, hydrogen, it's going to be an interesting market because a lot of the existing piping infrastructure, as you'll hear from one of the other finalists, and the valves won't necessarily be up to the job because hydrogen's a very small molecule. So the sealing technology is going to have to be a step above what's out there right now. But again, for us, we've designed out that sealing interface, so it's not a problem anymore. That emissions point is just completely gone. So yeah, that's why we're a bit better suited to hydrogen. Thank you.
Shaima, quick question, please.
What are the risks or obstacles in terms of deploying your technology from what you see?
The risk, it kind of depends on what level of service it's going into. Obviously, within a facility, certain valves are more critical than others, and it's all from a sort of risk management point of view, which you want to balance having an impact with necessary risk management in the plant. So as I explained, we have done some temporary deployments just to demonstrate basic functionality. It's already certified to the expected industry standards, so the kind of top level risks are already kind of mitigated against. So for us, it's kind of engaging in a good discussion with ADNOC about where the best places are for this valve and where they would kind of appropriately manage the risk accordingly. Thank you.
Thank you. We're out of time. Thank you very much, Chris.
Thank you very much. So, on to our third pitch of the day, which, if you hadn't noticed, we have startups from all over the world, but we're also lucky to have some startups from right here in the UAE, and our next startup is one of those. Our team members from this startup come from Yemen and the UAE, and you could probably guess where they are coming from just by their name. So please welcome to the stage Mira from Emirati CO2 to the stage.
Hello everyone and good afternoon. I am Mira Tahri and co-founder of Emirati CO2. In a world grappling with the consequences of climate change, Emirati CO2 stands at the forefront as a decarbonization technology provider. Our technology is a game changer for the most emitting sectors to reach their net zero target, especially focusing in power generation, oil and gas, steel and cement. Where all combined, they were emitting last year around 23 gigaton of CO2 emission, which baffling the boiling era this year. And to remove all that amount, we need 2.3 trillion trees, which is massive. Besides the CO2 emission, our technology will support the desalination plant, where they are producing around 142 million cubic meters daily, which is equivalent to 4 volume of the reject, which is equivalent to 4 volume of Burj Khalifa. And 60% of that amount is come from the MENA region, which is our region. And most of the companies, they are throwing back that reject brine back to the sea, causing harm to the marine life. So our technology will convert these challenges to opportunities. And so let's imagine that our system will be placed in one of ADNOC operation sites, where the air will be flowing, forcing by using a fan. The CO2 capture will be the CO2 will be captured using ion exchange sorbent, and the air will be flowing without the CO2. When the ion exchange sorbent will be saturated with the CO2, a rejected brine will be introduced to mineralize the CO2 into sodium carbonate, where it will be in a mixture, and that mixture will go for a further separation process to produce sodium carbonate. What you have imagined, it have been applied in our prototype, was shown in the slide, where we were able to integrate CO2 capture with CO2 mineralizing using reject brine. Our prototype were able to capture 1.4 kilogram of CO2 per hour, and in 1,000 ton per year facility, only we are required 0.31 megawatt per hour to capture 1 ton of CO2. And for 1 million ton per year facility that will be operating for 2 decades, we indicate a very competitive cost that will per ton of CO2. So why our technology is important and why it is needed? Besides that, we are solving 2 major problem or challenges that are impacting the world. The sodium carbonate market will be growing double the current market, reaching 21 billion. And that due to the demand in the pharmaceuticals industry, chemical industry, and also looking for the eco-friendly processes. That market will be created using our system, which will be aligning with the UAE 2031 vision, and that's set by the Ministry of Economy to reach 3 trillion non-export oil. Our technology will strongly contribute to the UAE decarbonization vision to reach net zero by 2050, and also will contribute to the vision of ADNOC to reach net zero by 2045. Besides, beyond the economically and environmentally impact, it will be also creating jobs along the supply chains. So, for the technology development and pilot part, our concept of the Emirati CO2 technology have been validated by the first generation prototype. And we believe a strong collaboration with ADNOC will improve our second generation prototype, leading to the second 200 ton per year pilot plan, where our suggestion that this plant will be in a waste industrial location due to the access of high concentration of CO2, the large objective product that is produced because of the process, and also to the access of electricity and transportation. And that can be built within an area of 900 meters squares within a 6 month till to 10 months, till it will be start working. That will lead the establishment to commercial plant starting with 1,000 ton till we are reaching 10,000 ton and reaching the million ton. So by we are scaling up that plant, we are decreasing the amount of CO2 in the air, which means we are decreasing the amount of trees that we are needing, and also decreasing the amount of rejected brine that will be throwing back to the sea. In the end, Emirati CO2 is not just a company, we are a force of change that is needed, economically viable, and strategically aligned with the UAE visions. So together, let's embark on the transformative journey toward a decarbonized and sustainable future. Thank you so much.
Thank you, Mira. So, time for questions. Ali is kicking us off. Ali.
Yeah, you just showed the scale-up plan, which is really great. So, what is your vision and plan to ensure that you are scaling it with cost-effective? Because this is one of the most challenges that we scale, but how about the cost?
Regarding the cost, when we did our evaluation, even it was first for 1 million ton per year facility, with considering all the land, considering the operation, considering the transportation, and all of that, we reached a very competitive net cost per ton of CO2, which this can be decreased further. I agree that the air direct capture technology is kind of new to this to the market right now, and due to the cost of operation and capital, it costs a lot, but it can be going for a further research and development, especially with the technology itself, to decrease that cost.
Thank you, Ali. Who's next? Myrtle.
Thanks. I've also got a question on scale up. So you're going from 170 grams of CO2 per hour all the way up to the tons per year. Is that too much of a scale up? Because that's a very high scale up rate. How confident are you that you'll be able to do that in such a short time?
For the pilot, can you repeat? Sorry, I didn't hear.
How confident are you about the scale up, given the breadth of the scale up that you're going from grams basically to tons?
So with the collaboration with ADNOC, what we are looking for is a further development and research, so we can be confident more about that scale up from reaching from kilogram to tons till we are reaching the 1,000, 10,000 and million. And what we are looking for is more a strategic plan in how we are want to develop our design itself in a way that will be capturing more amount of where the air will be passing more, which means we are capturing more CO2 and using also more projective ion. Yeah.
Okay, next question. Shaima and then Mohammed. Oh, maybe Mohammed, if you want to go next.
Sorry. In terms of your end product, so you're capturing the CO2 and then creation of sodium and calcium carbonate.
Yeah.
Where do you see the market with that?
For the sodium carbonate?
Yeah.
So there is a lot of demand, especially in the pharmaceuticals industry, the chemical, the paper, and also glass industry, which right now here in UAE, we are not demanding in the sodium carbonate production. So if we will be using that as creating that market here in UAE and then export it outside to the other worlds and countries, that means we are putting the UAE as one of the exporters for that sodium carbonate. And we are looking, we see that there is a room for that to producing that product.
Shaima.
How much funding are you looking for to develop your technology further to be able to do a large-scale deployment?
So for the 200-ton pilot, we are looking for like, which would be, it is like within the budget that will be given, which is 1 million dollar, sorry, which is it is between 1 million to 1.5 dollar. Yeah. Can I just say something that what we did in that our prototype is all was funded by ourselves and we are only like an employees. So by achieving that target and being able to prove that concept, it is really a big achievement for us. And this is what we want to look for that an Emirati project will be funded by an Emirati company to go further for the global level, not here in the world. Thank you.
Great. Okay, I think we're out of time, so thanks very much. Mira.
Thank you so much. So for our next startup, we have two more, and then we're going to go for a break. So our next startup has 6 members of this Dutch startup team who have over 150 years worth of experience in their business fields. And again, their technology clue is in the name. So fingers crossed you can guess what area this one comes into. Please welcome to the stage Jeffrey from CO2 Circulaire.
Thank you. Thank you, Edward. Thank you. My name is Jeffrey Felix, and I'm CEO of CO2 Circulaire, presenting to you SmartDoc. We believe that humankind will continue to need a carbon source in future. How would it be if we would all capture CO2 from the air, create negative emission, and at the same time generate the future non-fossil carbon source? So how? With SmartDoc. We apply membrane gas absorption to selectively absorb CO2 from the air. With electrodialysis using bipolar membranes, we're able to concentrate the CO2 to a pure grade CO2, and at the same time, fully recover the absorbent. Yes? We use a smart buffer system to make it possible that the 2 unit operations operate independent from each other, and we create by that the possibility to use curfew electricity as energy source. So what's unique on our technology? First of all, we use natural wind. We do not need any fans. Operation is 24/7 continuous. I mean absorption. So also during the regeneration and the concentration of the CO2, we keep on absorbing. We use a safe, non-toxic, fully reusable absorbent, and we only need electricity. So no heat, and of course, preferably renewable electricity. The concept is simple, it's simply scalable, and we only have a few key equipment items. Yes. We use mainly synthetic materials for both absorption as well as regeneration. This all leads to a real low OPEX, a low CAPEX, and as well a low footprint. So how far are we? Last year we built a mini unit achieving TRL5, and just 3 months ago we commissioned 100 tons an annum CO2 capture plant in Northern Ireland, sponsored by the UK government. So what's our plan for piloting in the UAE? First of all, we need to build a dedicated unit suitable for these climate conditions here, because really this is different than in Northern Ireland, in Europe. Everything is different here. Yes? We focus on collecting data, yes, for scaling up, scaling out, and at the same time select the best applications for the use of the green CO2. Of course, we'd like to involve the ADNOC specialists how to do things better and how to do things smarter. And like Edward mentioned, we would like to use our 150 years of experience within our own team. So imagine sustainable aviation fuel using CO2 from air as carbon source. Imagine ships on e-diesel or e-methanol made from CO2 and hydrogen from wind. Imagine accelerating the growth of vegetables or flowers in greenhouses using non-fossil CO2. Yes. So what could be the decarbonization impact for the Emirates? We have an emission here of 220 million tons a year. Our footprint for a smart dock is 0.5 square meter per ton an annum. Wanting to achieve the 2030 goals is 19%. We would be able to do that with 10 smart dock units of 2 square kilometers. Globally, imagine 10% of the global world's emission. We would be able to reach that with only 1,000 of these units. And potentially at zero costs as soon as we value green CO2 equal to the cost of capture. Thank you.
Thank you, Jeffrey. Okay, who would like to go first? Yeah, Ahmad, go for it.
Thank you, Jeffrey. Can you give us a bit more concrete examples on the use cases? So it's great that you're going to be capture all that carbon, but how do you see, monetization path? What are use cases you can use that carbon for?
Our first way of using the CO2 is after liquefying it, for direct uses, fizzy drinks, greenhouses, everywhere. Everyone who needs CO2 now and probably doesn't realize they're using fossil-based CO2. That's the short run. But for sustainable aviation fuel, for e-diesel, we need green hydrogen to combine and convert to this e-fuel. And there we work together with other parties in Northern Ireland, in the UK, in Germany, to make this happen. Yes. Thank you.
Who'd like to go next? Ali.
Thank you very much, Jeffrey. I like the way that you put exactly the plan to be scaled here in UAE, but you didn't really mention how much is the carbon capture that you are targeting to scale.
Yeah, that's a good question. For the, in fact, I would normally return the question, how much would you like to achieve?
As much as you can.
Yeah. Then we, then let's say we need to do this pilot test, because the pilot test is for taking into account where we differ here, and that's the climate. We need to know how it works under these conditions, working at 40, 50, 60 degrees C, and taking into account the dust, the storm. That's all what we don't have in Northern Europe, so we need to know how to handle that. But I'm sure we're able to do that together. And after that, then it's square meters surface area. And that's a half a square meter per ton per annum that we need for our technology. Yeah.
Next question, please. Yep, go for it, Myrtle.
So hi, do you need water in this process? I saw you had CO2 and energy going in, but do you need water?
Yeah. No, we need water, but only for creating the absorbent. So we don't have any consumption. We might, I know with the test pilot we did in Northern Ireland, in 2 months operation, we had to fill 710 liters.
Thank you.
But that was due to evaporation or our loss. Yeah, nearly nothing then.
Shaima.
You mentioned that you run completely on wind power. What is the amount of wind speed that you require to produce optimally?
Yeah, it's a very good question. We had designed our absorbent system for between 2 and 6x4. So wind power 2 to 6, yes? But if it's small, if there's no wind, we also have absorption. Because the membrane doesn't see if there's wind. There's 420 ppm in the air, so it will absorb. But if we have strong winds, we have even more. So below 2, we have less. It's like in a wind turbine. When you have more wind, you're able to generate more. And we use the flexibility of the weather. Yes.
So what you're saying is if there's zero wind, your solution will still be able to absorb carbon?
Absolutely.
At what percent capacity?
Yeah, that...
operational capacity, would it be like at 10% you'd be operating if there was zero wind?
I don't know the exact answer. I need to get back to you on that. I need just to calculate that. But just imagine the membrane is in air. You have 400 milligrams a liter there. As soon as it's absorbed, the CO2, there will be new CO2 there, because we can't influence that. So there it will be lower than with a wind of 4x4, but it will still be very pleasant, and it doesn't cost anything. It doesn't cost anything. That's part of the key. Yes.
Okay, thank you very much to Jeffrey.
Thank you.
Thank you very much. So our final pitch before our break, and we're going from the Netherlands all the way over to Houston in Texas. With our next pitch, which is coming here today. Their team actually spans 3 countries, and their CEO briefly worked as an emergency medical technician, and being the Scottish in the room, I have to say I like this part, another team member plays the bagpipes. So maybe by the end of the pitch, we might see some of that. Please put your hands together from Patrick from RevTerra.
The world is constantly driving towards cleaner and greener sources of energy and the decarbonization of existing industrial processes. There's no reason oil and gas can't participate in this trend And today, I'm going to talk to you about just one potential solution that my company, RevTerra, can bring to help you do just that. The specific application that I'm going to be focused on is the drilling for new oil and gas wells. Today, that process is very inefficient and very carbon intensive. The core reason for that is that an excessive amount of fuel is used every single day at each land drilling site. Just for perspective, every day, any individual site might use upwards of 2,000 gallons of diesel fuel to drill a new well. The reason that that's the case is often on-site generators are drastically underutilized. Why does that happen? Well, power needs at drilling sites fluctuate wildly. Anywhere from 0 to 3 megawatts for any individual given site, and that fluctuation can happen very rapidly and very unpredictably. What that means for operators is that frequently several generators are run in parallel to capture these spiky loads, and every single generator on site is underutilized, creating excess emissions and excess cost. That's where my company RevTerra comes in. We're building the next generation of kinetic energy storage solutions. Our battery is unlike anything you've heard of on the market today. Instead of using chemicals like lithium, nickel, or cobalt, we're using motion itself to store energy, largely in the form of spinning, recycled steel. Every single one of our modules can output a maximum power level of 2 megawatts and stores 100 kilowatt hours of energy. What that means in practice is that we can fully charge or discharge our battery in just 3 minutes. Why does that help in the drilling application? Well, instead of running several generators in parallel, you can capture all of those spiky loads with our battery system. You decommission one of the existing generators and therefore much more efficiently utilize the other generators that you have on site. You use less fuel, spend less money, and generate far less CO2 and NOx emissions. Traditional batteries oftentimes operate on a DC or direct current basis. This does not play nicely with the existing electrical operations at most drilling sites. Most drilling sites receive AC power from on-site generators and also demand AC power at most auxiliary loads. If you want to use DC batteries, that means you have to introduce power electronics components like inverters and converters. These are very expensive and very failure prone. Our battery, instead, is fully AC synchronous natively. We can completely forego those components and plug directly into your system with minimal modification. Much lower cost, much more environmentally efficient. Our battery lasts for upwards of 40,000 full depth of discharge cycles. In the field, this should be more than 20 years of usage. A traditional chemical battery would have to be replaced 8 times over that same period. That's a lot of waste. On top of that, our system sees 0 capacity degradation over its entire usable lifespan. It also creates no ongoing operational emissions and uses minimal emissions to create the product at the forefront. It uses almost entirely recycled steel as its input material, and it's fully recyclable once again at the end of its life. On top of that, it can be deployed across the harshest of conditions, anywhere from the driest and hottest of deserts to the coldest of winter conditions. It also requires nearly 0 ongoing operational maintenance, which means it's perfect for those remote deployments. We're currently at TRL level 6. We're in the process of building our very first commercial scale unit, and we expect to have it live with the customer at the very beginning of this coming year. From there, we expect to test the technology across several applications, including oil and gas, commercial industrial, electrification of mobility, and much more. So what would a pilot with ADNOC look like? Well, we would take the next 6 months or so to update our designs for this specific application and produce the actual unit. We would deploy it alongside one active oil and gas drilling land rig for the period of about a year. We would take anything that we learn from that process, integrate it back into our designs, and approach full commercialization in mid-2025. By doing just that one pilot, we can eliminate for ADNOC about 1,400 metric tons of carbon over 1 year. That's equivalent to 3.6 million miles driven in a gasoline-powered vehicle. If we were to help the entire land drilling rig market, we can eliminate 52.5 million metric tons of carbon over a 25-year period. That's equivalent to 135 billion miles driven. And that's just the start for us. We're not stopping with oil and gas drilling. We're doing many, many more types of applications. Things from enabling EV charging, backing up power for data centers and other critical infrastructure sources, and much, much more. This is what our technology would look like deployed in the field. If you're interested in hearing any more about what I've presented today, please come and find me after the presentation. Thank you.
Great. So who's first then in the questions? Myrtle.
Very interesting technology. So you're going to have this this device integrated into the plant. Does that mean you're going to have to match the shaft speeds of the rest of the rotating equipment in order to get this to work?
So one of the key differentiators of our technology is that it actually spins at the frequency of the surrounding electronic components. In this case, that would be 60 or 50 hertz, depending on the region of operation. But since we spin at exactly that speed, we actually interface directly without any need to modify the systems surrounding it.
Okay, that's interesting. Just a follow-up question. Does that mean then, in terms of the design precision, you're going to be designing and testing to this what you would do for a typical gas turbine, for example?
Yeah, this interface is exactly with the traditional kind of electric system around us, which includes primarily as the backbone gas or coal turbine generation equipment. One core thing that this would enable beyond the application of oil and gas drilling is full penetration of renewable energy sources, as we can actually provide full grid synchronous immediate inertia to the grid. So this is a pretty interesting technology on that front.
Great, thank you.
Thank you. Great technology. One question. What is your plan to get rid out of the 2 diesel genset? We have a plan 2045 net zero. So,
I'm sorry, I'm not sure I understood the question.
what is your plan to get rid out of the 2 diesel genset?
To do what with the 2 other
The 2 diesel generator.
Oh, instead of those?
Yeah.
So we could also interface directly on site with local renewable power if that's an option, and we can help further minimize the use of on-site diesel generation. Another thing that we could enable is traditionally if you're trucking diesel to the site, we can instead use flare gas or gas that's produced on site that would traditionally have been wasted elsewhere, and use that to use gas generation on site, which was infeasible because of the power step curves of most on-site land drilling rig power profiles. So several opportunities to reduce emissions further beyond just this.
Very good. Thank you.
Shaima, go for it.
You mentioned that you're currently about to deploy a pilot. Could you talk a little bit about that, and what would be the current capacity of the pilot unit that you're developing?
Yeah, the pilot unit that we're developing is exactly the one that I've shown here. It's a 2 megawatt, 100 kilowatt hour device. The actual deployment landscape for that project is for a semiconductor manufacturing plant, and they're actually using this for high voltage power quality assurance. So essentially cleaning the power profile of the local utility, and they will use this to protect all of their on-site sensitive machinery. This could be replicated at other industries like data centers, hospitals, and much more as well.
Great. A final question from anyone? Yeah, Ahmed.
What's your background, and how much investment have you received to date?
My personal background, I was briefly a landman for the oil and gas industry, actually negotiating mineral rights contracts. From there, I was a sell-side equity research analyst, so basically telling investors across the spectrum of energy where to place their capital for efficient investments. And then my team supports me with the much more technical concept that I've presented here today. As far as funds received to date, we've raised about $9 million, or a bit over that. About $8.5 million of that was in the form of a Series A equity funding that we completed in November of last year. That was led primarily by Equinor Ventures, one of the other large energy companies across the world, as well as several other VC or strategic investors that participated as well. We've also received about $1 million in grant funding from the National Science Foundation in the US, so we have support on that end as well.
And actually, we've got time for one more question. Any takers? Shaima?
If you win the prize, will you play the bagpipe for us?
Unfortunately, it's my team member that plays the bagpipes. I can sure give it a shot, though.
Great. Thank you so much, Patrick.
There we have it, round one. How did we find that? Round of applause for all of our round one speakers. Well done to you all. Excellent. Well, don't leave yet, because we have 5 more amazing technologies, from pipe fitting to bamboo to other types of carbon capture to digital technologies, all in store in the next hour or so. But we need to stretch our legs. So We have a 15-minute comfort break. There should be some catering possibly arrived outside. Feel free to get around. And what time are we at just now? We'll be back in the room at 3:05 for the second part. Thank you very much and enjoy. Welcome back to part 2 of our Decarbonization Technology Challenge. Hope you've had a fantastic break and you are ready for another round of fantastic pitches. We've heard from carbon capture. We've heard from novel types of carbon capture from all over the world. And we've heard of novel types of valves. And now we are ready for round 2. So we're going to again see some pitches. We're going to have 5 pitches, 5 minutes of pitch, 5 minutes of questions, including from our judges here. So let's get started. Our next startup is a Boston-based business that has team members from 6 different countries, and one of the founders was recognized as a Forbes 30 under 30. Please welcome Shiv from Active Surfaces.
Hello, I'm Shiv from Active Surfaces, and we're reimagining solar. To date, in history, we've installed 1 terawatt of solar around the world since the beginning of solar deployment. To achieve net zero, we need 20 terawatts. This gap is equivalent to the 2 gigawatt plant that was just announced here in the UAE a month ago, being deployed every single day for the next 2 decades. That's a lot of solar. There's big constraints. These things are heavy. They have interconnection queues that take forever, and soft costs now dominate the install. This is because the core technology that we use, silicon, is a ceramic, it's fragile, and it wasn't intended to be deployed outside of glass panels in the middle of nowhere. This panel in my hand is a silicon one. You see a lot of these in the thing outside, in solar panels all around the world. And it's inherently fragile. I'll clean that up, I'm sorry. This technology has even more limitations here. There's soiling that impacts performance, there's heat that lowers efficiency, and manufacturing that's not capable in the region. That is also a technology limitation. This is why people way smarter than me, MIT researchers, my co-founder, have spent a decade developing a flexible, lightweight alternative. Same power for the same area, but form factor that could be on plastics and fabrics. It's 120 times lighter, lower installation costs, and lower life cycle impact, less material use, less energy use during manufacturing. When you compare it to regular silicon, it's just as efficient, much lighter, cheaper to produce a panel, cheaper to install it because you save labor and structural, and all these other benefits, like it being flexible, you get better off-angle performance, better performance at high temperatures, more applications, less soiling, and the ability to regionally manufacture it. You may be thinking, Shiv, I've heard of flexible solar before. How come this hasn't already changed the world? Well, these other technologies haven't been able to win on the one thing that matters in solar, cost. And that's because they had low efficiencies, like SIGs at 15%, or durability that don't matter, like OPV that delaminates. How do we do this? Our secret sauce is a combination of manufacturing, packaging, and materials. In terms of manufacturing, we roll-to-roll slot die coat. This is a CapEx efficient process that is much faster. You can see the inks being printed on the left. In terms of our packaging, we have flexible packaging that is able to be laminated onto different materials. It's printed onto a plastic, and on the left, you'll see it transferred onto a plastic. And then onto a fabric. This is the fabric I'm holding up right now. So imagine solar curtains, solar shades, anything is possible. In terms of materials, we have record efficiencies. This is validated by NREL, which is the US national lab that validates this kind of stuff. And then we have REACH accelerated testing that indicates an early 10-year useful life. We could go after any market because flexible solar is cool and exciting. So where can we put this? We need to go after a market where we have an unfair advantage and where you can deploy a ton of it really fast. For us, that's low-load commercial warehousing. In the US alone, this is 6 billion square feet where buildings have to be retrofitted to handle the weight of solar. That's 100 gigawatts of opportunity, and you can save without having to reinforce the building, and you can deploy it like a yoga mat, rolling it on top of the building. You can put this literally anywhere. This is just the beginning. From facades, shades, cars, roofs, the possibilities are endless. Right now, we are TRL4. We just spun out of MIT this year, and we're heading towards a TRL6 in 2025 with a kilowatt installed on roof, and then commissioning our own manufacturing line soon after. To do this, we want your help, which is why I flew all the way here to come say that. How do we do this? Well, I think in terms of pilot, there's a huge opportunity with the 1 million tons of green hydrogen by 2030 goal from Masdar. Specifically, 50% or more than of the green hydrogen costs come from renewable energy. So if we can lower that cost, then you can make green hydrogen more affordable. Especially if you get better performance from the same area from every solar panel. On top of that, especially if you can generate solar in more places than was before possible. We broke this out into 3 different phases. We call it active 1, 2, and 3 because of the company name. The first would be a mini pilot of a kilowatt or 2, and this is tech development. How do we validate the manufacturing at scale? How do we make sure it performs with dust? How do you make sure it's stable and warm in high temperature environments? In active 2, we're focused on 25 to 50 kilowatt pilots. This is validating cost effectiveness at scale, installation efficiencies, and the form factor that we need to get this to the next level, which is active 3. This is larger pilots at the 200 to 400 kilowatt range that will help produce over 13,000 kilograms per year in total. But this is just the beginning. There's lots of other ways to collaborate, from the hydrogen that I mentioned to offshore applications where you can lower your carbon intensity and electrify using our portable and flexible form factor on offshore platforms. I used to work for Exxon, so I'm familiar with the benefits. And then Masdar could help unlock solar in different environments, as well as boutique chemicals that can help enable a circular economy. So if you can imagine a future where we can make any surface active, then join us.
Thank you. So who would like to kick off the questions from the judging panel, please? Yep, Mohammed at the end.
I'll start. So one of the challenges which the solar panels face is also the end of life, how long we have to replace them. So can you tell us a little bit about the film, the durability, and how long you expect them to last?
Great question. I also have an extra one if anyone wants to break it. Okay, so normal panels are intended to last 20 to 25 years. If you own panels, you know that's not true in field. It ends up lasting 10 to 15 years normally, and there are different environments that make that worse, like humidity or soiling. There's lots of impacts to that. So in terms of ours, we haven't done it at large scale yet, but early indicators give us a 10-year useful life. I think that the big drawbacks for solar lifetime is water. No, I think, this is research that my co-founder has told me, is water and oxygen ingress into the physical device. So if we can use our novel packaging schemes, which is printed in situ the physical device, so this looks like one thing, but it's 9 different layers printed on top of each other. So if we can use this packaging scheme to extend the life of these panels, then we can have a similar lifetime compared to the 10 to 15 that's actual, and have something that uses way less materials. So at end of life, you're not discarding solar panels, which are hard to discard with glass and materials that are hard to put in a regular supply chain, but something that uses commodity materials that can easily be ripped and replaced with something better.
Next question, please. Yeah, Shaima.
How does your, from what you've tested so far, there's a lot of issues of buildup on soil, on solar panel surfaces here. So how do you hope to address that with your technology in terms of efficiency and actual performance? And then also with regards to what my colleague asked about, how recyclable are these? So I guess it's 2 questions in one.
Yeah, no worries. Okay, so I'll answer the second one first because it's easier. We use commodity material that can use existing supply chains. The most prominent material in here is PET, and a lot of people are working on recycling PET right now, as opposed to silicon, which is a much harder recycling pathway. The first question was soiling, how do we address that? So a big problem with silicon is that under low light or non-solar noon, so normally when you look at efficiency, it's like how efficient is it when the sun is here and going straight down? If it's not that, then silicon has a much worse yield. And that's just because of like the way the inherent semiconductor is. Our material performs better at off angle and low light conditions. So at in the mornings and the evenings, and then if there's any kind of dust coverage, we're able to produce more and have less of an impact than traditional silicon. And also it's a glass versus packaging thing. Glass is inherently going to have more dust particles on it than if you use our anti-glazing on plastics.
Ali.
Thank you, Chef. Very interesting technology. So I can see that you are in TRL4. So what's your plan actually to accelerate this technology into higher TRL?
Yes, that's why I'm here. We, an OPV company, organic photovoltaics company, just bankrupted 2 months ago, and they sold their equipment, and one of our advisors used to work for them, and we bought it. So now we have a larger piece of manufacturing equipment, and we know how to retrofit it. Normally it's bad to do that because it's very expensive to retrofit stuff. But because we know the actual specs for it, we're able to validate the performance. So we're going to, long story short, we're going to use that in the coming months to start doing early demonstrations of the technology and go from TRL 4 to 6 much faster than we could have otherwise.
Ahmad.
A great presentation, but specifically, how would I saw the Masdar application? How would this specifically work for with ADNOC?
Yeah. So I mean, as you approach your green hydrogen goals, you're going to need solar deployment at scale. I think there's multiple ways to do this. One is you can just, instead of using traditional solar panels, you can test a novel form factor and then reinvent the places where you could generate green hydrogen. Right now, you're kind of limited to where you have large solar arrays. Now you can think about new applications for where you can do that. That's one. And then second, with the final page that I breezed through, was I think there's a lot of applications in offshore platforms. As you try to decarbonize and electrify platforms themselves, you need to generate on-site. And traditional solar panels are heavy and they're hard to put in all the unique creeks and crevices. If you can put flexible solar along platforms, I think that's a good way to do that as well. If this is the silicon, this is ours. And feel free to pass it.
Great. Thank you very much, Shiv. We're out of time.
See, now you've given me the opportunity. Even it's on time. What a cracking presentation that was. Way. Terrible puns, ruining the day. Okay, so time to move on to our second presentation of part two. This one, another fantastic global team. The startup is based in the Netherlands, but it has a team with 11 different nationalities and 3 different countries, including 2 yoga teachers and another recognized Forbes 30 under 30. So, from the skies down into water itself, please welcome Louise from Desolinator.
Hi, good afternoon everyone. I'm going to spend the next 5 minutes talking about our most critical resource crisis. Life as we know it today, our energy, food, manufacturing systems, all depend on water. But the way that we access that water today is unsustainable. And with rising demand, this is only going to get worse. While 98% of all of the planet's water is in our seas and oceans, therefore desalination, turning seawater into drinking water, holds immense promise. However, today it's an incredibly carbon-intensive and polluting industry, has very high energy requirements, it needs consumables such as membranes, processed chemicals, and involves huge, centralized, complex, carbon-intensive builds. Well, we at Desolinator envision a different future for the industry. We are Desolinator, a solar-based net zero desalination solution. The photo that you see here is about 100 kilometers away, done in partnership with Salal. Salal is the agricultural arm of the Abu Dhabi government, and in this project, we're providing net zero water.
I'm really sorry. We're going to have to stop because the judges can't see your slides on the screen. So let's take 2 minutes while we try and fix this technical problem. I'm
That's okay,
sorry
don't
to
worry.
stop you mid-flow.
I'll start again.
Yeah, we'll just give the team time to try.
They
and
could
fix
always
this
sit
issue.
here.
Yeah, if we can't get it to work, we will definitely do that.
That's all right. Nice to see everyone again. My name is Louise, and for the second time and second time only, I'm here to talk about the greatest critical resource challenge that we are facing today. Life as we know it on this planet, our food systems, energy systems, manufacturing, all depend on water. And yet access to water today is unsustainable. And with rising demand, this problem is only going to get worse. Well, 98% of all of the world's water is in our seas and oceans, and therefore desalination, the process of turning seawater into drinking water, holds immense promise. However, today, the industry is incredibly carbon intensive and polluting, with high energy requirements, requiring consumables such as membranes, processed chemicals, and usually involving huge, centralized, complex builds. Well, we at Desalinator envision a different future. Desalinator is a patented, net zero, solar-powered desalination solution. The photo that you see here is about 100 kilometers away, and it's a project in partnership with Salal, the food production arm of the Abu Dhabi government. And here, in a place that has no fresh water, arid soils, and extreme temperatures, we're growing high-value crops. And we are trying to be a step change in the desalination industry. We are a net zero, circular technology, delivering cost-competitive water in line with the future goals, sustainability goals of our planet. So how do we manage to do this? Well, it's really in two core processes of the tech. One, how we harvest energy, and the second, how we purify the water. So the energy harvesting is done with our patented PVT panels. This stands for photovoltaic thermal. And what we do is we harness the electrical and thermal energy. And those are the two ingredients that we need to power our entire system. The electrical energy is used to power our auxiliary equipment, our pumps, and the thermal energy is fed to power our MED vessels. This stands for multi-effect distillation. And essentially what we do is we take that thermal energy, apply pressure, and flash evaporate seawater or contaminated water, and then collect the ultra-pure H2O, which is also known as distilled water. We take that ultra-pure water and then we remineralize it to make it drinkable, or for example, in the Salal example, we custom remineralize it for optimal plant health and yield. The second part is that we like to think of ourselves as the Lego of the desalination industry. We have modular systems that are pre-commissioned and containerized, which allow for a rapid deployment and then minimal civil works on site. And all of this comes together to result in a 66% carbon reduction when compared with our competitors. And with the existing projects in our pipeline, we're on track to deliver 1.5 megatons of carbon reduction by 2030. And we're really fortunate to be already working with leading partners in the industry. So this is a photo. Actually, if you took the tube here, you would have passed it. But we managed to reach TRL 8 with the Dubai Electricity and Water Authority as part of their decarbonization strategy. And this is a deployment which is in the center of Jebel Ali and has been functioning for 2 years now. And whilst municipal water is a critical vertical, where we see immense opportunity is with the future of energy. And this is the $1 trillion opportunity that we want to explore with ADNOC. So to create green hydrogen, ultra-pure water is a critical ingredient because you separate the water molecule to get that hydrogen. Now, our competitors need extra technology and extra processes to be able to get that ultra-pure product. But for us, that is core to our technology and that is our core product. But we have another unique advantage, and this is the pilot that we're interested in for ADNOC. is we can actually take the waste heat from the electrolyzer and use that to power our MED process. This means a 70% reduction in PVT requirements, reducing our project costs by a third, our space requirements by a third, and producing some of the most competitive ultra-pure water on the market. But there's more. Like with everything in life, timing is so important. Green hydrogen is a nascent, very promising but nascent industry, and we can currently operate at the scale that is required with only 5 desalinator modules meeting 10% of the output goal, annual output goal of the UAE by 2030, at the same time as removing 330 kilotons over the lifetime of the tech. And this is one opportunity out of many, because water underpins all of our critical value chains. And it is a massive problem, and we cannot solve it together. We can only solve it together. It will only be done with partners who have a shared vision. And this is what we want to do with ADNOC, is dream big, start small, and scale fast together. Thank you.
Thank you. So, questions, please. Who'd like to go first? Ahmed, and then Shaima.
Congratulations on your achievements. And other than Dubai, have you done any other pilots? I would love to learn more about your traction, whether it's with clients or funding as well.
So maybe I'll start with the projects. All of our projects are in the UAE, mainly because desalination is such a critical industry here. Many of our investors are also from this region. So our chairman of our board is the CEO and ex-CEO and president of Aquapower. So managed $86 billion under management in desalination and solar. And one of the reasons that he invested in desalinator is because he wanted to do what he did for Aquapower for the mid-market. And that was where he saw the potential. We've raised about 8 million to date. From strategic investors. I think we're the only desalination company that's been invested by 2 ocean impact funds. And actually, even though we are based in the Netherlands, we're doubling down on the region. So we're moving our manufacturing here. We're creating IP within the country, and we're actually going to be slowly moving our commercial operations here, because we see this is where the opportunity is, and that this region has a real appetite for this kind of innovation and can finance it. So that's why we're here.
Shaima, and then Myrtle.
Thank you so much for the presentation. So what are some of the challenges you face when deploying your pilots in the region?
The main challenges we face is it is such, as we said before, water is such an enormous market. The core technology could be providing for a farm, for a bottling factory, for green hydrogen, and every single industry requires specific regulations, specific know-how. And we realized really on that we need to stick to what our core competencies are and bring in partners and expertise to support in that. So really our strategy has been about locking in the best verticals and working with the best partners to be able to do that, and taking specific roles and responsibilities within those relationships.
Myrtle and then Ali. Thank you.
Thanks. So interesting for the scale-up. Is your focus to scale up the technology that you have, which I suppose we may get issues around the size of the solar park, or is your part of what you're going to do is to really work on the efficiency to actually keep that in the manageable, to a manageable size?
So I think with any renewably powered technology, solar and the space required is a massive issue. But that's why we see so much potential to do something with green hydrogen, because by absorbing the waste heat, you massively reduce the amount of solar that you require. But there's also other industries in which you can do that, is capture the waste heat and use it to optimize the space that you need.
Ali.
First of all, great to see you working here in UAE. So based on your experience here and lesson learned, how you are going to accelerate the deployment of this technology here with ADNOC?
So I'm legally not allowed to say any names, but we're looking at a couple of joint ventures and strategic investments with UAE-based conglomerates.
Okay.
So that's our strategy. I'm sorry, I can't say who. I can't say who it is.
Thank you.
Yeah, Shaima.
Because you're solar powered,
Yes.
Putting aside the potential pilot with ADNOC with waste heat, what is your efficiency like? Like, how does your equipment run? Is it at 100% capacity, 90%, given the fluctuations in solar and buildup of, sediment on the panels themselves, and how do you average out?
Yeah, that's a great question. So, something that I would say is, with our PVTs, one of the patents is how we actually keep them cool and increase their lifespan because we're taking the thermal energy away from them, so we're actually making them more efficient. But we do our third patent is around how we store, manage, and recycle heat. So our CTO, who's the Forbes 30 under 30, but also has a PhD in thermodynamics, and it's how we harvest, recycle, and reuse the thermal energy means that we can operate 24 hours a day.
Okay, thank you, Louise.
Thank you so much. Now, our next founder, we are pretty confident is probably one of the furthest traveled to get here today. They live inside the Arctic Circle in very northern Canada, from the Northern Territory of Nunavut. But they've made it here today to talk about their amazing clean energy technology. Please welcome to the stage Solomon from Nunafab.
So good afternoon, everyone. My name is Solomon Amuno, and I'm here this afternoon to talk about our smart composite pipes for hydrogen transmission. As many of you know, hydrogen is the future, and one of the questions that everyone keeps asking is how can we transport hydrogen from point A to point B safely? And as many of you know, the traditional means of transporting hydrogen is using steel. But when you pass hydrogen through steel, a lot of changes happen to the structural integrity of steel. It loses ductility, tensile strength, making it very vulnerable to embrittlement, damages, and potential liabilities. Damages to pipes alone cost the industry over $1.3 billion annually. So how are we going to solve this problem? How are we going to ensure that hydrogen can be safely transported by eliminating this problem of hydrogen embrittlement? And that is what Nunafab has been working on for the last several years. We've developed a very innovative composite materials for transporting hydrogen that doesn't have the same problem of steel embrittlement and also very low in gas permeation. What also makes our technology very unique and very different from what is out there is that our TCP pipes are also instrumented with sensors, with fiber optics technology that can provide real-time monitoring data about what is going on inside the pipe and can also provide information on structural changes in the pipe. And that can help in terms of predictive maintenance. You don't have to wait until something happens before you react. And we can also monitor changes taking place in the pipes. Another very important component I would like to talk about this afternoon is, if you look at this graph here, I've outlined the various types of materials we've been working with over the last several years. We have TCP made from HDPE to PA12 up to PEEK and carbon fiber. And you can see that we have operating pressure from as low as 10.3 MPa to 137 MPa. We also have working temperatures as low as 65 degrees Celsius up to 240 degrees, which is very, very applicable for a place like the United Arab Emirates. Now, how does this technology work? So we have the pipelines. So we have the pipe already fitted with the sensors during the manufacturing. Data is collected from the sensors in the TCP pipe. That is processed through machine learning algorithm and fed into an AI system. The data is displayed on dashboard with predictive analytics. So basically, you can find out what is going on inside the pipe in terms of the flow rate, pressure, temperature changes, and also you can know what is going on in terms of if there's any creep, there's a burst, delamination, microcracks taking place in the pipes. And we can also localize any potential leaks or any kind of problems taking place in the pipe that could create an explosion. So that is what we've been working on. And also we can configure our sensors in such a way that they can be calibrated to be able to sense hydrogen in the air. We can set it up in such a way that it can provide real-time information, monitoring data directly on the cell phone that can help to monitor the conditions of the pipes. Another key component, again, is with this technology, you eliminate the issue of sending staff to go monitor the pipes, errors, and potential exposure to harmful chemicals. In terms of the carbon footprint, as you can see here on this graph, the carbon intensity of manufacturing our TCP is 50% lower than that of steel. And here I've broken down all the various ways that TCP is lower in carbon intensity compared to steel. And you can see here in terms of the materials, manufacturing, there's a significant reduction in carbon intensity. In terms of the life cycle emission of pipelines, steel versus TCP, as you can see here, life cycle emission of steel pipeline, 27.35 kg. For TCP is 6.8. We did a simulation, for example, trying to understand how much of emissions are going to be emitted if we have a 65,000 miles of pipes, of pipeline, the pipeline network. 9.4 million megatons for steel, and for TCP pipeline is about 2.3 million megatons, which is equivalent to about 2 million cars for steel and about 570,000 cars for TCP. So there's a significant reduction in terms of that. In terms of scale-up partnership, we currently have technical agreement with a major TCP equipment manufacturer in China called BIR. And currently, we've been doing some prototype manufacturing based out of China. And we are looking for an opportunity to co-innovate with ADNOC. And we, Anunafab and BIR, we're interested in working together with ADNOC to ensure that there's a local manufacturing of TCP here in the United Arab Emirates to be able to meet the local demands. So in terms of pilot demonstration, our goal here is to be able to manufacture a 10-kilometer TCP pipe that we would like to test with ADNOC to validate the technology. And we are hoping with that we can decarbonize hydrogen delivery. And this will be the first example that we have. This is our team based here out of Canada. And thank you very much.
Great. Now questions, please. Who's going to go first? Shaima?
Oh, sorry. I have a question with regards to your product differentiation. Can you please talk a little bit about that? And if you have any current patents or patents being filed. Thanks.
Thank you very much. In terms of product differentiation, we have two angles in terms of materials. And what actually makes our product very different from what is out there in the market is the integration of the sensor and the AI technology for predictive maintenance. There's currently no company right now, to the best of our knowledge, that has a similar product in the market.
Next, please, Mohammed.
So my question is on what's the largest diameter that you envision on the product, and then in terms of replacement. So are you doing it to spools, or how are you, how are you joining the pieces together?
Yeah, thank you very much. In terms of the diameter, we are going with the API 15S standard, and right now we are limited to just 8 inches, and that will come in spools. We're currently discussing a pilot with a Spanish gas company that are looking for a larger diameter pipe that is currently not covered under the API standard, and we're currently investigating that. But right now we are just producing just 8 inches. And in terms of the joint, we use electrofusion, welding, to be able to connect all the pipes together.
Yeah, Ahmad and then Ali.
Okay. No, go ahead.
Yeah, in terms of the predictive analytics, what's the confidence level of the outputs that you've observed?
So far, the confidence level is 98%. It's really, really very accurate, and this is the reason why we want to have an opportunity to be able to have a trial with ADNOC. We're also exploring potential trials also in Spain with a similar company to try out the analytics. But right now it's at 98% accuracy.
Ali.
Thank you. Very interesting technology. Also, at the same time, is very important. So, you are just limited in the hydrogen. Do you see yourself also looking at other applications like different diameter, talking about the geothermal, oil and gas type of applications?
Absolutely. And that was the reason why I put that slide that shows the variety of materials that we work with, from HDPE up to PEEK, that can take up to 240 degrees Celsius. So it's applicable for hydrogen as well as for other oil and gas applications that are even in a very, that requires high temperature, more harsher conditions. So we're also exploring that application as well.
Okay, I think we're out of time, so thank you very much, Solomon.
Fantastic, thank you so much. Second to last pitch of our day today. So our next one has 3 out of the 4 co-founders being competitive powerlifting. So let's hope they're going to take the weight of solving the planet's crisis onto their shoulders. And they have a founding team who collectively speak 9 languages. So please welcome Tawhid from Base 2 from Canada.
Thank you so much, everyone, for having me. Assalamu alaikum. My name is Tawhid, and I'm the CEO and co-founder of Base 2. So, with climate change, energy companies are under more pressure than ever to reduce emissions and achieve net zero targets. But unfortunately, traditional emissions reduction technologies are difficult to scale. They can be capital intensive or require significant equipment overhaul. But what if there was a faster path to net zero? Well, the secret sauce is in the data. Energy companies accumulate terabytes of data from their equipment sensors across their entire value chain that are largely underutilized. And that's because plant operators and engineers have to make hundreds of decisions every single day when controlling their critical equipment. And they lack the tools to understand how those decisions map to corporate emissions reduction strategy and policies. In other words, they lack the navigation system that can tell them how to get to that destination of net zero. So what if we could help them? That's where Base 2 comes in. Base 2 provides an AI co-pilot specifically for engineers in industrial environments. With Base 2, engineers can receive real-time recommendations on the next best action that they should take in order to reduce energy consumption and emissions. We're not just giving them insight on the current carbon footprint of their current decision making, we're actually giving them tactical feedback and advice on how to reduce that carbon footprint. So how are these recommendations generated? Well, we ingest data from multiple sources: DCS production data, lab quality data, as well as maintenance records. We also combine that with the domain expertise from the engineers themselves to train reinforcement learning models. What these models do is that they learn to reward controlled decisions that reduce emissions and penalize non-compliant decisions, all the while balancing economic and production targets. And our platform is very easy to use. It's been specifically designed for engineers who lack programming backgrounds. And in fact, the learnings that you develop from one plant can easily be scaled to multiple other plants. And that's why we're able to generate value in weeks, not years. So, what's our plan with ADNOC? Well, we plan to pilot on a single train at ADNOC's Das Island LNG facility. What we'll do is we'll leverage 1 year or 2 years of historical operational data to optimize the controls, first for the liquefaction control loops and achieve a 2.5% process improvement, as well as optimizing the desalination production by 7%. By doing that, we should be able to reduce the CO2 emissions by 22,000 tons during the pilot period, which is 12 months. When we scale that exact same technology to all 6 trains in the LNG plant and apply that same level of improvement, we can reduce the carbon dioxide emissions by 136,000 tons at the Das Island LNG facility. That's equivalent to taking out 30,000 cars off the road every single year. But it doesn't end there. We don't have to just do LNG. In fact, we can add value to many different ADNOC business units, from upstream drilling to downstream refineries, such as the Ruwais refinery, as well as chemical business units like Ta'aziz and Borouge. And in doing so, we believe we can save up to 1.5 million tons of CO2 emissions by 2030. So why are we the right company to do this? Well, we have a track record of successfully deploying AI with Fortune 500 companies with a TRL technology of level 8. We've deployed with Johnson & Johnson in Europe for one of their chemical manufacturing plants, where we were able to demonstrate an energy savings of up to 25%. We also supported NOV in the US with optimizing drilling sites in order to reduce diesel fuel consumption. And there we are able to see 12 to 20% optimization reductions. But it's not just the company and our track record. We're backed by a solid team that can deliver on a pilot and scale thereafter. Our founders have built and scaled an AI climate tech startup that was ultimately acquired for $1 billion by Autodesk in the water industry. We've also received $6 million in VC funding to date, despite only starting the company a year ago. And we're backed by some of the top VCs in the Boston and Bay Area, as well as Boeing and the UAE's Security and Defense Council, Tawazun. We've got 20 team members on the team, and we're not just a bunch of data scientists. We also have significant industry experience in the oil and gas domain, as well as process engineering. So, to conclude, we're at the halfway point since the Paris Agreements. And if we want to hit our targets by 2030, we need solutions that are fast and highly scalable. And we at Base 2 believe that AI is exactly that technology. Thank you so much. Shukran.
Thank you, Tawhid. So, who would like to go first? Mohammed, I can see.
So looking at the LNG trains on Das Island, so there's 3 LNG trains. 2 of them were commissioned in 1978, and the newest one was commissioned in 1994. So pretty, aging technology, and you will have a new LNG plant hopefully commissioned by the end of the year, by end of the decade, which is very low carbon. So in terms of your the AI and the integration with the technology, what are the challenges or how much can you get out of an aging plant versus a current new build, a greenfield project?
Yeah, thanks for that question. That's a great question. So when it comes to aging infrastructure, what we see is that they tend to deviate from their design points. What that means is that they're running at a lower efficiency point on the design curve. That means that there's actually a greater margin for optimization using AI. So what we do is we look at how much is drifted from the design point and identify what is the optimal set point given its current age. So actually, if it's older equipment, there's a larger margin for optimization.
Okay, who'd like to go next? Yeah, Ahmad.
A couple of questions. Where do you train your models on, and what are the different applications? Because I know, honestly, a model like this, it's endless what you can adopt.
Yeah, thanks. That's a great question. So we use AWS SageMaker. We run our models on that infrastructure, which is highly scalable, means we can train a lot of models very quickly. In terms of applications, like you pointed, there's a lot of different application areas. For example, earlier today we heard about optimizing diesel consumption for drilling rigs. That's something that we've done in the United States and that we can continue to do by using like a smart management system to optimize when these diesel generators turn on or can be turned off. We can also optimize in chemical facilities, distillation columns. We can optimize in the refinery, crude, FCC, hydrotreaters, as well as some of the things I mentioned with LNG and compressors and the liquefaction cycle. Yeah.
What's your business model? How do you make money? Is it just by deployment? Is it SaaS?
It's a SaaS. Yeah.
Speaking about the money, so what is really your approach on value to ensure that there is a value realization at scale?
Yeah. So our approach is really to demonstrate with the pilot how quickly we can learn from the data that's provided to us and showcase the ROI. As soon as we've done that on a single type of process, we then scale that to every single other version of that same process type. And we can do that extremely fast. Like, I'm not talking about months, we're talking about weeks. And we did that, for example, with Johnson & Johnson. We started on a single plant, took about 4 weeks, and then we immediately moved to the commercial plant, again, in a matter of weeks.
Any more questions? Yeah, Myrtle.
Hi, you mentioned that engineers knowledge is involved. When you did the Johnson & Johnson, did you manage to decouple that at any point, or are the engineers still there intervening?
Yeah, so when I meant like we tap into their domain knowledge of the engineers, sometimes they know things that are intuitive. For example, some pieces of equipment have constraints. Like they can only run between certain frequencies, or they can't be turned on or off at certain times. So we capture that knowledge and we introduce that as an interface where they can put in those constraints without needing to code. And that's how we capture that type of edge knowledge that wouldn't be visible from the data alone.
And one last question we got time for, judges? No? Okay. Thank you very much, Tawhid.
Thank you, everyone.
Thank you very much. And we are on to our final pitch of the day. Now, for those of you who are in the room here in the green zone, when you walked in to today's Energy Transition Hub, perhaps you noticed the tree of life as you walked in, or some of the plants, or maybe you've noticed the backdrop here. Well, tonight's last pitch is all about that. We have our final founder, who's actually from just up the road here in the UAE, and it's a business that is going to be telling you all about nature-based solutions. So please welcome our final pitch of the day, Arshi from Oxygenate Bamboo.
Bismillahirrahmanirrahim. I'd first like to take this opportunity, being the final presenter, to thank you all for your time and for your patience. Let me talk about the most common practice that we do in our daily lives. We fuel our cars 50 times a year. That means we're spending 170 hours of our life each year just fueling our cars. Now, why do I talk about this? Why is this important? This is typically an average service station snapshot. What does that mean? Massive carbon emission, unfortunate proximity to the residential areas, heavy sandstorms, grey infrastructure, massive humidity, wastewater generation, limited green cover, potential crashes. also very costly, and the most unfortunate being fire explosions. It is recorded that in the United Arab Emirates, every day we experience minimum 9 car crashes and fire explosions. Today is the most polluted day in the United Arab Emirates. An ADNOC service station produces around 7,859 tons of carbon emission per station per year. Today, the technologies for direct capture in terms of air, in terms of chemical, and also mechanical are not just energy intensive, they are expensive, but also at the same time a source of further emission. For the first time in the world, we introduce carbon neutral service stations, the energy station of the future, a culmination of technology plus nature. We utilize 2,000 oxygenate bamboo trees in 20 ADNOC service stations, 100 trees per station. Why oxygenate bamboo and why bamboo? It may interest you to know that globally there are more than 1,600 types of bamboo clones. We have taken one particular clone, modified it to tissue culture micropropagation process, a product of nearly 40 years of research in botany and biotechnology. What does that do? Massive carbon sequestration. On an average, a tree, a mangrove or a garf tree or even a wild bamboo will not sequester more than 10 to 12 or 30 kgs of carbon dioxide. One oxygenate bamboo tree will sequester a minimum 400 kgs of carbon dioxide annually. On an average, a human body requires not more than 280 kgs of oxygen to breathe. One oxygenate bamboo tree will generate more than 300 kgs of oxygen, enough for a human body to breathe for their lifetime. It grows at a massive speed, 1.5 feet per day, which is visible, can be verified. Reduces temperature by minimum 4 to 5 degrees, a massive hit in terms of the targets, global targets, in terms of temperature reduction. It is stronger than steel. It is regenerative, so we never replant it ever in our lifetime. It grows on its own for the next 50 to 100 years. The major feed for the oxygenate bamboo is carbon and humidity, products that are easily available, especially in our part of the world. And the most important, again, being that this heavy carbon sequestration will be decarbonized into renewable energy, biofuels, bio-CNG, and multiple other products, because bamboo is now, for the first time in the world, can be utilized to produce renewable energy sustainably for the next 100 years. Now, what is a carbon neutral service station? It is the energy station of the future. So we utilize one carbon service station. We plant 100 bamboo trees. What would that do? Minimum sequester, 44 tons of carbon dioxide, generate 32 tons of oxygen, reduce air, water, sandstorm, noise pollution, reduce temperature. It also consumes 2,000 liters of wastewater off the service station that could be utilized to irrigate the bamboo plantation. It is a massive fire, sandstorm, noise, and crash barrier, 100% biodegradable, 100% carbon sink, and will reduce the plastic consumption of the service station. Now, this is what an ADNOC service station with oxygenate bamboo visually look like. The visibility in terms of the growth can be easily mapped here from before planting to 4 months to 1 year of planting of the bamboo tree in terms of the growth. With 20 service stations and the total pilot with the bamboo, we would minimum in 20 years sequester 11,520 tons of carbon dioxide, have a wastewater consumption of nearly 40,000 liters per day in 20 ADNOC service stations. The harvest can then be utilized for creating bio-CNG. 1,000 trees would effectively generate minimum 4 kg of compressed natural gas, would also create 1.2 liters of bioethanol, would also create 1.2 liters of biodiesel. However, with this harvest of 2,000 trees, we propose the creation of more ADNOC service stations, because everything that you see over here, everything that the human eye can potentially see, can be made 100% from bamboo. As a company, I am Dr. Arshi Ayub Muhammad. I am the CEO and founder of Oxygenate in the UAE. Our team comprises of chief scientists who have combined experience of nearly 80 years in research and biotechnology. In the past, we have supplied to companies like Tata Consultancy, Wipro, Infosys, and the UAE company has also had innumerable interactions globally. We also have a global mission that starts as a UAE company to plant 10 million bamboo trees, sequestering minimum 600 tons of carbon dioxide by 2030, by the way of creating oxygen parks, oxygen forests, creating bamboo utilities, air approach barriers. We can create bamboo-based construction, carbon-neutral freeways, carbon-neutral pathways, because the global market of bamboo just today stands at 66 billion. However, this is only for a normal bamboo tree, and I will show you how a wild bamboo and oxygenate bamboo differs. I'm fairly confident that even though a bamboo is the most underrated solutions in the nature base, less known, less implemented, however, it has the highest efficacy, not just in terms of climate, but also in terms of industry, in terms of global warming, and finally also providing more and more employment to local farmers. Now this is what on an average a bamboo in comparison to a wild bamboo look like. What you see over here is a wild bamboo, and this is how an oxygenate bamboo looks like. This is not just carbon capture, it is also carbon capture and storage. On an average, the productivity with 1,000 trees would be minimum 40 tons. Minimum 40 tons. And the harvest would be 4 times a month because of the exponential growth rate. I'm really looking forward to join hands with this country, each one of you, to be able to decarbonize and understand that oxygenate bamboo is the next disruptive solution for global warming. Thank you very much once again for your time and consideration.
Thank you, Arshi. So we've come to our last questions. So who would like to go first? Ali.
Thank you, Dr. Archie. Very interesting technology. I have 2 questions actually. Number one, what is the eligibilities actually to generate carbon credit from such very interesting technology? This is exactly number one, eligibility of the carbon credit. And more second question, this is all, you've managed to put it into kind of technical point of view, but from business perspective, how do you see that we can go ahead and generate values out of just capturing the CO2 from bamboo?
Thank you so much for the question. The first being in terms of the value proposition and what we generate in terms of in and out. Bamboo as a harvest is massively utilized for the agenda that ADNOC has in terms of creating more service stations. So we first utilize this for the harvest in terms of the construction. And in terms of carbon credit, the present market is quite in its infancy. So we understand and we propose an independent accreditation that could verify how much carbon capture, statistics on air pollution, statistics on reduction in noise. So we ourselves recommend independent accreditation on carbon credits so that everything that we speak, everything that we claim can be verified by independent carbon credit accreditations.
Ahmad, did you have a question?
Always. So a couple of questions. One, is the bamboo grown here? And you said 4 months to 12 months, just confirming that that's how long it takes. And the last part of that is it, as you think about fuel stations or other construct, is it more cost effective? Is it as cost effective as traditional buildings?
Thank you for the question. Bamboo in terms of construction definitely is taking away 60% of your cost, because remember, this is a regenerative resource. The more carbon emission and the humidity, it will constantly keep growing with the water that we are using at the service station. So in terms of cost effectiveness, I don't see another solution which will give me perennial product continuously for the next 50 to 100 years. That's one. And in terms of its tensile strength, it's much stronger than that of steel. So we can build everything and swap cement industry, which utilizes 0.5 ton of coal for every 1 ton of cement produced. We can utilize that as a replacement for bamboo. And for fuel stations, which this may be very effective, is because today as we go and we have these massive interfaces between the Sheikh Zayed road and the longer roads of freeways, we are under a real danger because of the potential crash and the potential fire explosions close to a petrol station. This would actually mitigate that by nearly 70% minimum. So in terms of a humanitarian one, in terms of cost effectiveness, in terms of decarbonization, in terms of desertification, reforestation, 0% plastic, wastewater consumption that is utilized by a service station, this has massive, massive value.
And Shaima, last question.
I saw in your presentation you talk about places where your bamboo has been deployed, and one is at I think Tata.
TCS.
Yes, and then the other is at Infosys.
Infosys, Wipro.
And this is, where are these located?
In different campuses of theirs. So we have it in India, we have it in Philippines, we have it in Kenya, we have it in Sri Lanka.
Perfect.
And in the UAE, we registered the company in the year 2022. Till now, we haven't done a pilot project, which is what we intend to do with ADNOC, so that the correct statistics can be identified.
Right. So my next question, actually, and my colleague also kind of asked you, is bamboo native to this part of the world?
So bamboo is non-indigenous to specifically this region, but it is the most effective for this region.
Right. Because my concern, well, I'm curious because the solution is a monoculture. And every plant that you introduce to a new environment has an allelopathic impact. And for those of you that don't know, that means that a certain species could have impact on the native species of the environment. So have you studied that to really see, could this potentially become an invasive species? Because, as you said, it doesn't require, it's not an annual, it doesn't require reseeding, and it can continue to grow. So how will it compete for the limited water and soil that we have, if you've thought about that?
Thank you so much for this particular question, and I'd really like to add some of this to your fantastic question. This is a sterile, non-invasive species, and we can also conduct agroforestry with this. The reason why I mentioned, because when we plant it in 4-feet trenches, or for that matter 12-feet trenches, we can do agroforestry in between the bamboo. It is a natural air conditioner. It will not impact the ecosystem around it. In fact, it will only make it better. The water consumption is in terms of the wastewater savings that we identify with bamboo, and 100% sterile, non-invasive species, because that's what a wild bamboo does. This is the one that we have modified in terms of tissue culture and micropropagation process. Another thing that's very important is that in terms of fire, you can easily catch fire with a wild bamboo because that's a dry bamboo. What we have developed is a green bamboo, so it cannot catch fire. It's 100% termite resistant as well. And another thing is in terms of reptiles. You will have species that can actually stick in a wild bamboo. This bamboo, you will have 0 species that can actually invade, so 100% non-invasive.
Okay, time is up, so thank you very much to Ashi.
And there we have it. That is all of our pitches for today. A round of applause for all of our fantastic startups. Congratulations. It's been many months of hard work pulling all of these pitches together to convince them, but now I'm afraid the tables have turned and the hard work is now on our judges, who now have to make that big decision which one of these technologies is worthy of a $1 million pilot opportunity. We will find out in about 20-25 minutes. So our judges are going to go into their deliberation room. There is hopefully some more catering available outside. Our aim is to be back in here by 4:35 to find out who our winners are. So please stick around, have some catering, network. The toilets are in the visitor center next door, and we'll find out our winner in about 20-25 minutes. See you very soon.
Great. So welcome back into the room. So pleased you're all here to hear the exciting news. There were some great discussions in that room over there. We've overrun by 10 minutes, but that's testament to 10 fantastic startups in a really fiercely fought competition. But anyway, I am very honored to announce Sophie Hildebrand, CTO of ADNOC, will be up and announcing our winners. So, Sophie.
Thank you so much. This has been an exciting journey. This started in May, and it's culminated today. And we at ADNOC and all the members of the Decarbonization Technology Challenge, we were amazed by 650 applicants that we received from all around the world. Great technology, great ideas. So screening through all the applicants, that was a big job. For all of you who are here today, the 10 of you who are here today, thank you so much. You did an amazing job, and I know that the judges were having some challenges in the room, lots of great discussion, but really, there may be one winner today. I would say, as we've gone through this process, I've learned an awful lot. I've been looking at your technology and going, oh wow, this one paired with that one looks really interesting. I think there's, for those of you who've been watching in the room, there's great technology, great applications, and just because whoever is the winner today doesn't mean that you're not going to get opportunities to work with people who've been committed to this process. So I want to thank everyone for your participation. I want to thank our partners, our judges, and all of you who've joined us at COP28 here in Dubai. This has been an amazing journey for all of us. So with that, I know everyone's eager to hear. I would say that the judges have given us a couple of commendations. So the first commendation is going to Oxford Flow. So Oxford Flow really recognizing that methane is a really significant challenge for us. It's a challenge that's with us right now. So congratulations. The second commendation goes to Base 2 AI. And now the moment you've all been waiting for, the winner of the $1 million piloting opportunity with ADNOC is RevTerra. So once again, I want to thank everyone who's been part of the challenge. The 10 who pitched today, you did a great job, great technology. I see application for all of you. And let's keep up the good work, because together we will decarbonize our world. So thank you so much.
And there we have it. We have our winners. But as always, as Sophie has said, You're all winners, so well done to all of you. This brings us to the end of our Decarbonisation Technology Challenge. We want to do a couple of very quick thank yous. So from the operational side of things, this has been a massive team effort for months. So in particular, thank you to Atlantic Council and the venue team, the AV team, who have worked incredibly hard to support us with hosting this in the green zone, which we really appreciate. So a round of applause for all of our technical geniuses. From each of our partners and also from the Net Zero Technology Centre, a huge team of people from judges that each of your partners has contributed to, marketing staff, to technology support, has helped guide the startups, provide support. So a massive thank you to all of our partner teams for supporting with this as well. Round of applause. We've also had logistical support from Hub 71 as well, who've helped provide some of the various catering, and BP have also supported as well with things as well. So thank you to our other partners. Round of applause for them too. And for me, a couple of thank yous, mainly to our audience, from those watching online and those who have stayed. Whether you've been here the whole day or dipped in or out, we appreciate your time. Thank you very much. So a round of applause to you as well. Thank you. And I'll pass over to Mark for our closing remarks and final thank yous.
Thank you very much, Edward. And indeed, it's been a brilliant afternoon, and we've heard some fantastic pitches. And we can't wait to hear more from each and every one of you. So many thanks again. So this brings us nearly to the end. I would like to say a special thanks, though, to ADNOC who created this challenge, who funded it. It's been brilliant working with ADNOC, so thanks very much. Let's have a round of applause for ADNOC. And I would also like to thank our 5 brilliant judges. So we have fantastic partners in BP, in Hub 71, in AWS, and in the Net Zero Technology Centre, if I may say so. So thank you very much. We really appreciate your hard work this afternoon. So thank you. So I think that covers it. So thanks so much for attending. Hope it was a really enjoyable afternoon. And please stay for some more networking. And I think there's plenty of food left. So, and yes, we'd like some pictures, please, of all the startups up on the stage with the judges. So please do hang around, enjoy each other's company. And yeah, well done again. Thank you.